Okay, guys, for this binary to decimal and decimal to binary lesson, um, you're going to follow these instructions, and I provided 4 different worksheets, okay? The first is the binary counting card foldable template. So let me go to that real quick. And so you guys will see something similar to this in the worksheet. You won't see these numbers. I didn't put those on there. But the directions cut around the outside border. So you cut around the outside border, right? I wouldn't cut the dashes in first. What I would like you guys to do, first, let's talk about where these numbers come from. Okay, so these are your decimal numbers. You guys are used to the decimal system, all right? By now, after watching this video, you know that computers understand binary, which are just ones and zeros. So we got to figure out how to convert decimal to binary and binary to decimal and back, okay? So where do we get these decimal numbers from? Well, we've got 2 to the 0, which is 1, 2 to the 1, which is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7th is 128, okay? So from this, each of these is a separate bit. So this would be 1 bit, 2 bit, 3, 4, 5, 6, 7, 8 bits, okay? Now, you guys will see on your, 256, 512, 10, 24. That's just adding, 256. That'd be adding another bit here. 512. But we just start off with this. We don't need to, for really big numbers, we can add more bits, or we can switch to like a hexadecimal number system. But we'll do that later in the future, all right? So what I want you guys to do for this is what you'll do is you'll cut out the outside of this, and then you'll flip the page upside down, okay? And so what we'll do is we'll put a let's see here. I'm gonna highlight this, and I'm gonna center it. And where's vertically center? Table properties. So alignment, center, row, column, cell, and we'll center it there. And then we'll put in, and I'll make this a little bit larger too. We'll put in a, now again, this is going to be on the back side of this, not on the front side. So it would be, you wouldn't see these numbers on the back side, all right? So you'll just put ones right here. So 1, 1, 1, 1, 1, 1, and 1. And then here, let's do again table properties, center, vertical, and center. So I got, okay, let's do this right there. We got zeros here, 0, 0, 0, 0, 0, 0, 0, and 0. And you would actually, again, you're not using the computer on this, you're going to be typing this out, or you're going to be writing this out by hand. Okay, alright, cool. Let's make them bold too. Then what you'll do, so these are going to be written on the outside. Then what you'll do is you'll cut from here to here where the dotted line is on each of these. Okay. And then you'll be able to fold these on, so one represents an on, and 0 represents an off. And I'll demonstrate this in class because I think we'll have at least the first day in here to demonstrate how to use the foldable. But that's pretty much the end of this document. So what you should do now is pause this video, and then you should print out each one of these papers. So the code.org, and again, I have them uploaded, the secret message, and the binary conversion worksheet, okay? Right now I'm going to go on just to show the answers, but if we were in class, I would hand you the worksheet, and then you would have, I don't know, 10 or 15 minutes to work through it. You guys need to practice working this kind of stuff out by hand. I don't think you're going to get it just by watching the video. So this is where you'd pause the video, and I will start going through this. Okay, so anyway, so the first document that you'll print out is this binary practice, okay? And so it's telling you that you need to, it's a good idea to learn the first 16 digits, all right? So with your foldable that we created, you'd have a 0 over your 8, a 0 over your 4, a 0 over your 2, and a 0 over your 1, and that would represent a 0. For a 1, what would represent a 1, you'd have a 0 over your 8, a 0 over your 4, a 0 over your 2, and a 1 over your 1, and that's a 1. So the number 2, you got a 0 over your 8, a 0 over your 4, a 1 over your 2, because that's the 2 is now activated, and then a 0 over your 1, so that's 2. So then you do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. Okay, so let's go down and look at the answers to this, okay? So 4, you've got a 0 over your 8, your 4 is activated, and then your 2 and 1 are zeros. 5, right here, you got a 0 over your 8, a 1 over your 4, a 0 over your 2, and a 1 over your 1. And the reason why you would do that is because 4 plus 1 is equal to 5. So your decimal number, 4 plus 1, your 4 gets activated and your 1 gets activated, and 4 plus 1 is 5. 6, you've got a 0 over your 8, you got a 1 on your 4, and then a 1 over your 2, and then a 0 over your 1. So 4 plus 2 is 6. And you can kind of go through these with your foldables. So fold up, what equals a 7? Well, 1 plus 2 plus 4, that's a 7. Your 8. Well, your 8's represented through your fourth bit. 9, you got your 8 and your 1. 10, you got your 8 and your 2. 11, you got your 8, 2, and 1. 12, you got your 8 and a 4. 13, 8, 4, and then 1. And you'll start seeing these patterns, and at first, just going an 8 and a 4 and a 1, what is he talking about? Again, go back to this. When I'm saying an 8, a 4, and a 1, that's 8, 8 plus 4 plus 1 is what, 15? Or whatever I'm saying when I'm going through these, because I'm kind of going through them quick, all right, because you have the answers. Okay, and then you can go backwards, right, because the next thing is that they're giving you the binary, so put your zeros over each section, and then where your 1 exists you would, so this is the number 4, so all these are 0. 8's a 0, so it doesn't get activated. 1 here gets activated, so on your, on here, your 4 is here, and so, that gets activated. And so then you can kind of look through my answers here, okay? So 16, 32, 64, 128, okay? Okay, and then what I did is I gave you the practice problems here, where I'm showing you the numbers. So 100, that's equal to a 4 because the 4 gets activated and these are zeros. 5 is a 4 gets activated and a 1, so 4 plus 1 is 5. And then you can kind of look through the math on all these. Okay. Now, what gets a little confusing here, I didn't make a foldable for 256 here, okay? But all I did was just added on another bit, and then the same for 512. I added another 1 on, which would activate the 512, and so on and so forth. Okay. One thing that kids can get confused of, typically when I write these out, I don't add the leading zeros on. So you can either add those or not add those. Either way, it's up to me. Like this number right here is the exact same thing as writing it out like this. Okay, so those are both the same. Okay, so there's a simple pattern for determining if a binary number is odd or even. What is it? And why does this pattern occur? Well, okay, so again, we go back to the foldable. Notice that all these numbers are even, right? And so anytime you add an even number, you get an even answer, okay? So 2 plus 2 is 4. 4 is even. 2 and 2 are both even numbers. 4 plus 2 is 10. 10's an even number. 8 and 2 are even. All right, so what would stand out here to know if a number is even or odd? Well, 1 is an odd number. So if this last number right here is on, and represented as a 1, you know that the number is odd. If it's a 0, it's an even number, okay? And that's what I wrote. If the first number is a 1, it is odd. If the first number is 0, it's even. Okay, how many bits would you need if you wanted to have the ability to count to 1,000? Well, the binary number 1,000, I should have put a 00 there. The binary number 1,000 is represented by this. The decimal number 1,000 is represented by this binary number. And how did I get that? Well, again, I just go back to my foldable. Only with 1,000, 1,000 is going to be greater than all these numbers combined. All these numbers combined are 256. So I need to be able to add in, 2 more bits to be able to add up to 1,000. And so what I did was, okay, I needed 2 more bits, so 512, 256, 128, 64, 32, 16, or whoops, wrong one. 512, 256, 128, 64, 32, and 8. If you add all those up, they give you 1,000. And so the 4, 2, and 1 are all zeros in here. Also, what did I skip here? The 16. The 16 isn't added in there. So that's 1,000. So how many could you count in binary if you used wait a second, let me go back here, because I gave you the 1,000, but I didn't say how many bits it would be. So all I did was count these. So this is your binary, I converted it, and so how many bits is it? So from here to here is 1 bit, 2 bit, 3 bit, 4 bit, 5, 6, 7, 8, 9, 10. So I need to have 10 bits to be able to represent the number 1,000, okay? And then, so how high could you count if binary, if you used your 10 of your fingers as bits? 1 finger is up and down is 0. So I would just write out 10 ones. So 1, 2, so again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 10, 10 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one would represent the finger on. And so then what I do is I just add them up. So 512, 256, all this adds up to 1,023. So you can count to the decimal number 1,023 with 10 bits or 10 fingers. Okay? So this is where you would stop this part of the video, and then you can open up, let's see, what's the next document? So the next document would be the secret message. So you would stop the video, open up and print in your secret message document, and then work on that, and then you could come back to this video, and then we'll check your work. So this is where I'm going to start the secret video. Okay, so the trees represent ones and the blank spaces represent zeros. Okay, and so your numbers will these numbers 1 through 26 will represent your letters below. Okay, and so all I did was I just did the same thing, which you could go back and do. Find your foldable. You got 1, 2, 4, 8, and 16. And so the first tree that's on is represented by the number 8. Okay, and so the rest would be 0. So I would go down here and look for the number 8, which represents the letter H for help, and it'd actually be lowercase. I think that switched that for me, but help, or the whole thing is help, I'm trapped, but I'm trying to show you how I got to this. So I got H for the first letter. Then I've got a 4 and a 1. 4 plus 1 is 5, so that's an E. So that's where my E came from. Then I've got 8 plus 4 is 12, so that gives me my L. And then 16 is a P. Next one is blank, so that would represent a blank space, so I put my blank space right there. Then I've got an 8 and a 1 is 9, so the number 9 is represented by an I. Then I've got 8 plus 4 plus 1, so that's 12, 13. So I go down here, 13, I got my M. Then I've got another space. 16 plus 4 is 20, that's my T. 16 plus 2 is 18, that's my R. 1 is represented by the A. Then I've got 16 and 16, which is my P's, 2 P's. And then I've got a 4 and a 1, which is 5, that's an E, and 4 is D. So help, I'm trapped, and you can see, well, sorry, I don't know why this picture's here, but help, I'm trapped. It's a Christmas picture. Maybe Santa got trapped in the fireplace or something like that. So anyway, this is again where you would stop. You would be, you would just check your work, see if you got that correct. If you didn't, watch the video. And then finally, this last one for this lesson, binary conversion worksheet. So make sure you do the worksheet first, and this is the section of the video where I'll start this. So again, you'll see something like this that you printed out, and then I have the answers. Okay, so you should do this all by hand instead of just looking at the answers. But so you got the number 120 or 145. In the way that I would just think about this, and you're probably gonna have to do this in your head, but 128 is less than 145, so you know that's going to be involved in there, so you put a 1 there. 128 plus 64, what is that? 128 plus 64, that's 192. So 192 is greater than 145, so you know that's going to be a 0. So 128 plus 32, that's 160. That's also greater than 145. So that would be a 0. But then we get to the next one, 128 plus 16, and that's 144. 144, when you add those up, is less than 145, and so then you just keep doing the process here. If you added an 8, that'd be greater than 145, all the way till you get a 1 here, and there's your number. Okay, so next thing what you do is you just plug these in, and then you add them up, and there's your binary number. Okay, and that eventually equals 55. So again, what I would do is I would practice all this. I gave you the math behind all of it, and I put in the answers, the binary answers, and you can see the math, how I solved all this stuff. Okay, so again, you're going to need to do this work. I'm not going to talk through every single number and how it all adds up, but you can see how I got the answers here. So, and for this video, this is it.